Greetings class, welcome to Math 1030 online videos. So we have the unit 3A, which is uses and abuses of percentages, to do today. In this video I'm going to follow the handout that is posted on Canvas under the course calendar for this section and explain more in detail about what how kinds of topics we're going to cover about percents, and then are in the example solutions, which are also posted. So they begin with a definition of percent, which quite literally means per 100. Okay, and the book also has a definition that a viewpoint is divide by 100. Okay, so handling percents is they're trying to handle percents in as basic a way as they can. So divide by 100 or per 100. Okay, and they begin with a couple of exercises where we convert percents to fractions and percents to decimals, and then vice versa. So the first we're going to do is we're going to do 3.5% converted to a fraction. Now when you convert 3.5% to a fraction per 100, okay, that means we put the 3.5 in the numerator and the 100 in the denominator. Oops, let's go back. Okay, and what we need to do is we also need to simplify it as much as we can. So we're going to set that equal to something, or simplify it, and there's no decimals in a fraction, so we're going to multiply both the numerator and the denominator by 10. 35 over 1,000. So 3.5% is the same as 35 over 1,000. And then we're going to divide the numerator and denominator by 5, okay, which will get 7 over 200. In our next example, we have the decimal form of 3.5%. Now converting percents to decimal is also not very difficult. We can take the percent and then divide by 100, okay? So we're going to take the percent, 3.5, divided by 100. And when we do that, we get, we can move the decimal 2 places to the left to get 0.035, okay? And then the next one is going to be the percent form of 0.45. Okay, so it's 45 hundredths to percent form. So what we're going to do is we're going to change that to percent, which means we take it and we multiply by 100. Okay, and we're going to we get move the decimal 2 places to the right. We get 45%. Oops. And then the last thing we're going to do is we're going to take a fraction, turn it to a percent. We have 1/5 as a percent. Okay, so 1/5 in the book they say just to divide it. Okay, so 1/5. So we do with our calculator, we divide 1 divided by 5, and we'll get 0.2, which is then we're going to take it and we're going to multiply by 100 is equal to 20%. Okay. So that's kind of our review of percents. All right, in this next video, we're doing number 2, which is using percentages to describe change. Okay, so we have to think about first what absolute change is. Okay, absolute change means the actual increase or decrease from a reference value to a new value. Okay, so actual difference from reference value or an old value or the starting value to a new value. Okay, and the next one is relative change. Okay, the relative change is the size of the absolute change in comparison to reference value expressed as a percentage, okay? Size of absolute change in comparison to the reference value. As a percent. Okay. So what is the reference value? Well, the reference value was the starting number. The reference back that up a little bit. Is the starting number. And then the new value is the new number. So we're looking at a change. Okay. Okay. Now there's a formula for the absolute change, which actually is the difference from the reference value to the new value. So absolute change is equal to the new value minus the reference value. And then the formula for relative change relative change is, again, the size of the absolute change in comparison with the reference value. Okay, so we're seeing how the difference from the new value from the reference value relates to the reference value. Okay, so it's a comparison there. So that's equal to the new value, subtract the reference value, divided by the reference value. Okay, or we can say that is the absolute change divided by the reference value. Okay, and in this one, so I'm going to put this back up here. So now let's go ahead and look at an example. So it's part G. The estimate for the population of the United States was 282.2 million in 2000. The estimate of the population is 327.2 million in 2018. So what are the absolute changes and the relative changes in population? Okay. So first we'll do absolute change. In U.S. population. I'm taking my new value, subtracting my reference value. So my new value is 327.2 million, subtracting off my reference value, which is 282.2 million. Okay, and when we subtract those, we get 45 million. Okay, and that's the absolute change. And so the relative change, in U.S. population between 2000 and 2018 is I'm going to do the shorter formula for it, which is the absolute change over the reference value right here, these two. Okay, so I can already say, oops, sorry about that, that the relative change is the 45 million, this right here, divided by the reference value. Now the reference value again was the beginning number, the starting number. Okay, starting number. The reference value is going to be 282.2 million. And I'm going to multiply that by 100%. forgot to put that up on here, times 100%, because we want this as a percent, and that's how we are referring to it as a percent. And when we do that, we get 15.9%. So the division between 45 million and 282.2 million is 0.159. And so that's approximately equal to 15.9%. Okay, so we can say that the increase in population was an increase of 15.9%. Okay, next we're going to do number 3, which is using percentages for comparisons. And part A talks about what absolute difference is. Now, comparing percentages together is similar to changes in percentages. So we have an absolute and we have a relative. So the absolute difference is the actual difference. Found just by subtracting, similar to what we've seen before. Okay, the actual difference between a compared value and the reference value. Okay, and so when we have an example of a comparison, okay, we say that something is more than the other or less than the other. Okay, in the book they talk about a cost of a Lexus car being more than the cost of the Mercedes car. I actually think Mercedes or Lexuses are more than, okay, being less than the cost of the Mercedes car. And vice versa. The Mercedes is probably costing a little more than the Lexus. Okay, and so that's our example there. And so we want to do the compared value and reference value. The reference value is whatever comes after less than. Okay, so whatever comes after than. So we have the cost of the Mercedes. Okay, so in this case, if the Lexus is being less than the cost of Mercedes, then this is the reference value. And then the cost of the Lexus is going to be the compared value. Okay. All right. Now, what is relative difference? Okay, relative difference is the size of the absolute difference in comparison with the referent value as a percent. Okay, size of absolute difference in comparison to the reference value. So we compare it to reference value. As a percent. So we want to say like the cost of the Lexus is a percent less than the cost of the Mercedes. Okay, when you compare them. All right. So we have a formula. There's a couple formulas in. So absolute difference formula. The absolute difference is equal to the compared value minus the referent value. Okay, and then, okay, so we're just, And then D, the formula for the relative difference is equal to the compared value minus the reference value divided by the reference value. Remember that the reference value is the one that comes after and, or than, sorry, than. Okay. So in part E, we have a situation to investigate here. So we have the median income of a family in Utah is $71,414. The median income of a family in Idaho is $55,583. Okay. So what are the absolute and relative differences between the price difference from Utah, how much more it is, than Idaho? Okay, so Utah is going to be the compared value, Idaho is going to be the referent value. Okay, so we have our absolute difference we're going to calculate first. That's equal to 71,414 and subtract that from 55, subtract off 55,831. Okay, and so when we subtract those, we get 15,831. I'm sorry, let me back up here. 55,583. Let me cover that down right. Good. And then our difference is 15,831. Okay. So that's our absolute difference. And so the relative difference is equal to the absolute difference, okay, which is going to be 15,831 divided by the compared value. So not the compared value, but the reference value. We're referring to Idaho here, so put that one there. And the 55,583. And when we do that, we're going to also multiply by 100% because we're going to change that to 100%. And that as a percent is going to be 28.5% higher. So approximately equal to 28.5% higher. Okay, so in summary, we have for our examples that the median income for Utah is 28.5% higher than, remember that's our keyword, than the median income for Idaho. Okay, here we are in problem number 4, part number 4. Of versus more than. Of versus more than. Okay, when you're comparing things with percents, a lot of times people confuse these two. And so for an example, I looked up how stock increases for the company of Intel. So in 2010, Intel stock was worth $20 a share. In 2020, the stock was worth $60 a share. Okay, find the following. We have the new stock price as a percent more than the original stock price. Okay, here we use relative change. Okay, so we can use relative change here for this one. And so when we're doing this for our example, we have the new stock value, $60, subtracting off the old stock value for our absolute change, and then dividing it by our old stock value. Okay, so to find the relative change, so percent more than. Okay, so when we do that, we're gonna, we also have to multiply by 100%. And so we have $40 over $20 is equal to, or times 100%, equals 2 times 100% equals 200%. Okay. So with the relative change, we can say that the stock has grown by more than 200%. Okay, the new stock price is 200% more than the original stock price. Okay, a couple ways of saying that. In part 2, we're going to talk about the stock price, new stock price, as a percent of the original. Okay, so we're going to use absolute change here. Okay, and so we do our $60 over our $20, so our new amount over the old amount times 100% equals 3 times 100% equals 300%. Okay, so the new stock price is 300% of the original stock price. Okay? And that's different than the new stock price being percent more than, or 200% more than. Okay, so we illustrate this difference because people confuse them a lot. Okay, in this video we're doing number 5, percentages of percentages. Percentage points versus percent. Now there's a slight difference here, and it's very subtle. So again, we're going back to absolute and relative. Change or difference in percentage points is an absolute change. Okay, so in part A, number 1, that is absolute. We put the word there. Okay, and then part 2 has relative change. So change or difference in percent is a relative change. Okay, so absolute goes with percentage, where you're just dealing with the percents themselves. Relative is a percent change. Like it goes up by a certain number of percent, or goes down by a certain number of percent. Next, we talk about an example. At the end of 2016, the unemployment rate was 4.7%. At the end of 2019, the employment rate was 3.5%. What was the change in percentage and percent? Okay, so we're going to do percentage change first. And sometimes you want to see what that is. So percentage change means I'm going to do an absolute calculation, which is the difference of 3.5%, which is the new value, subtracted 4.7%, which is the old value. Okay, so absolute difference. And when you do that, you have a decrease of 1.2%. Okay, so unemployment went down by 1.2 percentage points. Okay, 1.2% as in percentage points. Okay, now the percent change is a little bit different. Okay, it's a relative amount. Okay, and so what you do is you take the absolute change, which was the minus 1.2%, and then divide it by the old value, the initial value, 4.7%. And when you divide that, you get about a 26% decrease. Okay, so we can say that the unemployment rate had a 20% decrease from, and is now at 3.5%. Okay, here we are with number 6, part number 6. solving percentage problems. In life, we encounter a lot of percentage problems, mostly sales or tax or tips or things like that. And so there's a formula that they start out with in this part of the final value of a percent problem is equal to the percent, or 100 plus the p percent, okay, times the initial value. Okay, and so we can also arrange this as if we want the initial value, we can set that equal to, by dividing both sides by the percent, this part right here, the final value over 100 plus p percent. Okay, so that's the formula. A lot of times we use this for tips. So you take your tip, the initial, you take your bill, so which is the initial value, do 100 plus p percent for tip, like maybe 15, 18, 20%. And then when you find that 100 plus p percent of the initial value, you get your final value, okay, which is which you end up paying. Okay. And what we have for our example, we have a couple examples, so that's part A. Part B. John bought a TV for $500. The sales tax in Utah is 4.85%. How much did he end up paying for the TV? Okay, so how much did he end up paying means that we're looking for the final value. Okay, and so the final value, again, was the initial value times the percent. So 100 plus the percent. So in our case for Utah's sales tax is 4.85%. Okay, so we'll do that. And the initial value in this situation was the TV for $500. Okay, so when we simplify this left side of the right side of the equation here, we get 104.85% times the initial value of $500. When I convert this percent to a decimal, 1.0485 times $500, we multiply those two together and we get 524.25. Okay, so after tax, his TV was 524.25. The next situation is where we are given the final price, the final value, and we asked for the initial value. So John also bought a Nintendo Switch, and he just saw that he paid $314.55 after tax. So assuming that he purchased it in Utah, which has a 4.85 sales tax, sorry, that should be 8.5, how much was the retail price for the Switch? Okay, so we have our initial value part equal to the final value, which was $314.55 divided by the percent. So it's the 100 plus 4.85%. Okay. And that's the problem. So we're going to simplify this part. So the initial value is equal to 314.55 divided by 100 for 4.85%. And that's equal to 314.55 divided by 1.0485. When you divide those numbers, you get $300 according to the calculations. Okay, here's our last section, number 7, which is about abusing percentages. So the last part of the text. And our classic example for shifting reference values, as that's what classical abuse is, dealing with salary, percent increases, percent decreases. Okay, and so if you percent increase something and percent decrease something, it's not going to be ending up at the same amount. Okay, so our classic example is, say that you earn $100,000 a year, And your boss says times are good and you get a 10% raise. Okay, so we have $100,000. And then we're going to have a 10% raise. Then, after a year at that salary, your boss says times are not as good and you get a 10% pay cut. Okay, so are you going to earn as much as you did before? Why or why not? Okay, so $10,000. We have $100,000, 10% raise. Okay, so let's see what our new salary will be. And when we do that, we take our $100,000, multiply it by the 100 plus 10%, like this. And then we will simplify this by doing $100,000 times 110%. That's going to equal, according to my calculations, $100,000 times 1.1, which is equal to $110,000. Okay, so after your raise, you'll get $110,000. Now there's a cut that's going to happen, and so we're going to do a 10% cut. So we'll start with our $110,000, do our 10% cut, which means we're only going to use 90% of our salary, and we calculate that by doing the 100 minus our p%, or 10%. Okay, so that's equal to the $110,000 times 90%, which is equal to $110,000 times 0.9. So 90% of your salary is equal to, according to my calculations, $99,000. Okay, so obviously you didn't end up back where you were before. So where is this discrepancy coming from? Okay, and if we go and look at the 10% raise, what is this 10% referring to here? Okay, this 10% is referring to, let me go to a different color here. Oops, sorry about all that. Okay, so we have our 10% raise here. That's where it's coming from. So this is 10% of $100,000. Okay, and when this is our reference point here, our reference is reference value is going to be of the $100,000. Now, what are we doing here? In this step, we are going to finding a 10% cut of, okay, so this is the raise, this is the cut. We're affecting 10% of $110,000. Okay, and this difference in price here and here are the reason why you don't get the same amount when you go 10% raise and 10% cut. So I hope that that video and all of these other videos will help you solve the homework problems. So good luck with that. Let me know if you have any questions. Thank you, and we look forward to the next videos.